All right, good evening, everyone. This is Celso Batalha, Show 10, Astronomy 10, online course, Evergreen Valley College. And few things before I start with the discussion today is next week we have an exam. That's going to be the midterm number one. And what I put in the syllabus is that you have the option of doing the exam online and at home. And that is the same for all the exams, the three midterms and final exam. According to online, um, in fact, online suggestions done by the distance education division or department here at Evergreen, we are supposed to have 50% of our exams proctored. So what I do 75% of them proctored, except one. And usually the exam that I don't make it online is the final exam. So the final exam, in fact, the only one that I don't make online is the final exam. Sorry, the only exam that I make it online and without proctoring is the final exam. Usually, that's what I've done. But it so happened that this coming Tuesday, when the exam is supposed to be delivered, I have jury duty, and so I'm not supposed to be here at 4 o'clock. So unless I mandate all of you to do the exam online and proctored with Proctorio, which I think I would be breaching some regulation because some students don't want to be in camera, and that's what happened when you use to do the exam online and at home with a software. You have to have a camera. Camera has to be filming you all the time, and pretty much that's it. So I decided to swap, and the final exam will be proctored, but this coming midterm is going to be pretty much done online without proctoring. So what I do on Tuesday evening, I will send you the password, and then you use the password to access the midterm. So basically what you have the entire day to complete the exam. So it's pretty much one day. But the exam lasts for 1 hour. So I would recommend not to try it 11 p.m. on Tuesday because there is always something happening at last moment and you might be on trouble. And pretty much that's it. So Tuesday I will not be proctoring the exam. I will not be at Evergreen, and you can do it at home online without being proctored. The questions are kind of multiple choice questions. You need to know the subject. You don't expect it to Google answers at the last moment because it doesn't work that way. Um, and pretty much it. Any question?
Can we use any notes?
You can bring, for all exams, I allow 1 page back and forth of notes. You can try to squeeze as many information as you want. You cannot put questions and answers in there. And what you do when you do proctoring exams is online, you go to the camera and then show your student ID, and then you show the back and forth of your notes. And then you start the exam. You cannot leave the room. You cannot talk to anyone. Anyone can be there. You cannot have a second screen open. Um, yeah, that's it. You cannot open a second browser, and pretty much Proctorio tracks all your motion and send me a report and flag if something is weird. Obviously, any system can be broken. Okay, so this week we are dealing with Newton's law and the beginning of modern astronomy, and I'm following the discussions you guys are making with respect to prograde and retrograde motion, and I thought would be interesting to show that in action with a software. Let me pull it up here. By the way, my screen is being shared, right? So you can see my screen. correct? And you can hear me well.
Yes, we can see it.
Okay, so this is a software. Let me see if I can pull it here. Okay, and pretty much September 25th, 2008. So I think I showed this before, and by the time of the day that is now force, I will speed up the time flow. And as we learned previously, if I speed up the time flow, as you can see here, sky objects slowly appear to be moving from left to right as you face south. This is south. So they move from left to right, and slowly the night comes in. You see Venus kind of going away right here. See that? That's Venus. This might be Jupiter. If I bring the ecliptic, you see the planets close to the ecliptic. So that's Mars coming in, and then this is the natural progressions. Now, transport yourself 3,000 years ago, and that's what you observe. If you can kind of keep track of what's going on out there in the sky, that's what you see basically. And then the appearance is that we are immovable in the center of something that includes all the stars and even the moon we see. They slowly seem to be progressing around us from our left-hand side to our right-hand side if we face south. In other words, from east to west, passing through south at the maximum height. And so it's obvious, if you don't have any information about astronomy, to assume that we are immovable in the universe, center of the universe, and all those objects happen to be going around us, because that's a reasonable deduction based on what you observe. The problem is, and now I'm going to bring, in fact, it's not a problem, but it's a cool thing that happened. If we bring the names of planets and into consideration, and so in those days Neptune was not visible, neither Uranus, right? They were not visible. But the moon naturally seems to be progressing also from east to west, and we know nowadays, and we studied in chapter 2, this is due to the fact that Earth is spinning on its axis of rotation, and that's why we see the sky behaving the way it does, like that. If I speed up the time a little bit more, let me see it from 300 times to 3,000 times. Let's go a little bit faster. And then the sun is going to rise. It's another day. And then I would get rid of daylight, right? Just so that we can see the planets coming in. And then you have Venus and Jupiter, Saturn, Pluto, it's not a planet, Mars, Neptune. So they all go from east to west, from our left-hand side to right-hand side on a regular basis. Now, these people in the past, they were not stupid. They were not, doing nothing and just fighting and trying to survive. I mean, they were observant. They were pretty much us, living 3,000 years ago. So they start making maps of this night sky. And so imagine that one of these maps is you observe the stars, you observe, let's go back here. So you make a map of the sky. Certainly this, with the sun in the sky, you can't see Jupiter, but pretend this is night sky. And you have Jupiter and Venus, and you carefully mark the position of Jupiter or Venus in respect to, let me see this star over here, Arcturus? So I would take this star Arcturus in Boots. Oops. And I carefully mark the separation between Arcturus and Jupiter. Oops. Of course, they couldn't do that 3,000 years ago. But you mark and you say, okay, I have a separation of 39 degrees and 25 arc minutes. So you mark this today. That's the position of them. That's how apart they seem to be in the sky. So certainly you have to use some good technique to get that precision, but imagine that you mark 39 degrees, more or less. If you build astrolabes with protractors, you can get 1 degree precision in angular measurement. So let's say we can get one degree precision, and then we are reading a separation of 39 degrees. And then we advance a few days. So what was the separation? 29, I said? 39. So let's advance 1, 2, 3 days. So 3 days later, same time, right? You go to Arcturus and you measure its angular separation from Jupiter. Oh, you got it exactly 39 again, a little bit more. It was 25, now it's 46. So 3 days was not more. So let's take more days, more than a week. And then we do the same. Separation between Arcturus and Jupiter. And now we are in the 40 degrees and a half to be more precise. So which means this planet Jupiter, in respect to Arcturus, their separation is changing. So if you have a map of the stars, this object called Jupiter seems to be moving in respect to the stars. And then you're curious, George, and then what do? You say, okay, I have Arcturus. Is this the same thing happening with another star? So, and then you take another star, let's say this one over here. Hazalyagi, what a funny name. Razalyagi. And then you track the separation of Razalyagi, which is a double star, with Arcturus, and then you get a distance of 48 degrees, angular separation 48 degrees in the sky, right? And then you advance several days. See, I'm putting almost a month. And then you do the same measurement, because you're very precise, you have good tablets, good rocks, and then you have the same 48 degrees. It doesn't change. So basically, for somebody living 3,000 years ago that had enough time to map the sky using techniques we could discuss some other day. So now you have a map. Imagine the wall in front of you. You have all these stars well cataloged and positioned. And then you have these weird stars, Jupiter, Mercury, that in respect to other stars, they seem to have their own independent motion. So these stars were given a specific name, planets, basically. That's where the name planets came from. That means wonders. So you have the so-called fixed stars, because although they move from our eastern sky to our western sky every day as we see it, there are also some other stars that decide not to obey those rulings, and they have their own independent motion. That's where the planets were found. And if you go to books in archaeoastronomy, they claim these 7 stars, and they became sacred later when religions became organized. These 7 stars were Mercury, Venus, Mars, Jupiter, Saturn, the 5 visible planets, plus the moon and the sun. So seven stars. And supposedly those planets, Sun was considered a planet, and as well as Moon, were identified thousands of years ago, probably 10,000 years ago, year 7,000 BC. There are indication these stars were already kind of indicated. I mean, they are different, which is not difficult to see. Sometimes you see Venus in the eastern sky, and then a few days later is in the western sky. So they know some weird thing was happening with some of these objects out there. Okay. Now, now you advance in time and go to a point in civilization when you try to explain why things behave the way they do. More so, especially after Mesopotamians have invented astrology, as well as Indians in India and Chinese. They invented astrology, and now stars and these planets were considered gods or semi-gods or intermediate between the gods. The stars, planets were the intermediate between those stars, God and us, and they had some influence on us. Now you have a whole religious system called astrology, in which to predict your future, what you're going to do in the future or not, you must be able to consult an astrologer. So the astrologer would lay out the horoscope, the astrological chart, and then make predictions. Here's the interesting aspect of it. To make predictions, you have to know where the planet's going to be. To predict the future, okay, should I marry my daughter or not with that guy? Oh, sorry, talking about daughter. Should I marry my daughter or not with that guy? Um, the answer is, let me ask the astrologer. So for the astrologer to answer that, the astrologer has to know where Mars should be and where Jupiter should be, where all these planets should be. So depending on their configuration, they could make predictions, right? Because the astrological system is such that we have stars in the constellations of the zodiac that send some influences, but the planets, they have their own characteristics. They can enhance or they can diminish those characteristics. They have good and bad attributes, and they can influence depending on which houses, which astrological signs they happen to be inhabited in the months you want to make predictions. So for that, oh, I need to know where the planets are. And then you have to incorporate mathematics into your prediction, and pretty much that's how mathematics, predictions, and science got to be developed in regards to astronomy. Um, so let's go to the geocentric worldview and the heliocentric worldview, which is part of the current discussion. And I saw some of you put nice figures explaining both systems. I saw the geocentric worldview. No, I saw the heliocentric worldview. Somebody posted a picture. I don't remember. Excuse me. Just a second. Sorry. Um, it's so how to explain that. Wait a second. Move this away. And we can do by doing the following. Oh, so in the discussion, I saw the heliocentric worldview explanations, and I didn't see. I don't remember of seeing cycles and epicycles. But let me take a look in our book and see what is being said in there. change my browser. I can't find the animation. There you go. So there you go. So this is a typical geocentric worldview. So see this blue dot over here? This is Earth. So Earth, to make predictions to be accurate, and astrologers need that in those days, Ptolemy, he had to move Earth out of the center, and that's when the model started to get a lot of fudging to allow observations um, to meet the theory basically. And around Earth, those are the constellations of zodiac, and here's the path of the sun, or the path. This is the path of the sun. So the sun is going to go like this, and this is the path of a planet. Okay. So if you allow the sun to go around these stars of the zodiac, and you keep track of a planet, Mars. So Mars sometimes seems to be retrograding. So in respect to the stars, as you look at Mars, so you're here and you look at Mars and you see the Mars going backward. This is called retrogradation, right? And it still retrogrades, and now it starts slowly progrades. Now, I think this model is ingenious, and the reason is when you see Mars in progression, like here now, Mars also is further away from the Earth than it is when it retrogrades. Now Mars retrogrades. So when Mars retrogrades, see the proximity of Mars to Earth? Mars appears very bright. And this is true. So when Mars is retrograde, Mars is bright. And that's how the geocentric worldview would explain. So the retrogradation has to do with the fact that Mars gets closer to Earth, and Mars is indeed going around in a circle around the star, right? In fact, to run the animation more precisely, you have this whole thing going on. See that? So Mars go around Earth according to the geocentric worldview, orbiting a point that happened to be moving in circular motion around Earth, uniform circular motion. Let me see if I can reproduce here, like this. See my errors is going a circular motion, and Mars goes around that in a beautiful circle too. So circle around the circle. And that has to do with this Neoplatonic and worldview that circle was the best representation of God in the sky. And since the sky was supposed to be harmonious, any type of motion should be broken down in a combination of motions in circles or spheres, right? So the projection of Earth on the moon during lunar eclipse was a circle. The projection of moon shadow on Earth was a circle because moon was a circle, and so on, and so on, and so on. So circle was the dominant idea, and we know this was very okay, except that Mars was not meeting with the required precision to grant this model um, some validity towards the future. And then came modern astronomy. In fact, first it came geocentric worldview. Let me see if I have an animation for geocentric worldview. I don't think they have one here. Oh, they do. There you go. Now, this is a heliocentric, but with the orbits not in circles. So this is a heliocentric with the orbits as given by Kepler's law, I suppose. Let's see if that's the case. Yeah. So in this configuration, the sun seems to be immovable, but in fact, the sun is moving, uh, wobbles a little bit because of the gravitational pull of these other planets on it. So there are few motions that the sun goes through. And second, planets don't describe circles around the sun, but orbits that are elliptical. And the laws of Kepler are those that govern the planetary motion in our solar system and in other systems. And Kepler's law um, became part of a major theory, the gravitational theory developed by Newton, in which gravity force is the one responsible for guiding and for controlling and the motion, the planetary motion in our solar system. Okay. So in Copernicus' worldview, which was the heliocentric, and he didn't include ellipses in his model, planets would go around the sun in circles, but the model was not good, was not precise, was in fact giving worse results than the geocentric worldview. So what Copernican people did was to fudge the model and including epicycles as well. So these planets would go around the sun, not in circles, but in epicycles. And small fudging motions would be introduced to match observation with pretty much theory. But the fudging is not a good thing when you have a model. In science, you don't want to fudge a model. You want to fudge a model if you realize, okay, there is a problem here, I can solve it, don't have that explanation, let me put some fudging factor here. Maybe in the future that might be explained, like Einstein introduced a lambda factor to make the universe stationary, right? When he created his general theory of relativity. The equations were such that the universe would collapse. To prevent a collapse, he created a fudging factor that, okay, now with this factor I can overcome gravity, and then all stars, and it's going to stay in the same position, galaxy forever and ever. And then later on, when Hubble found the expansion of the universe, so it was a blunder in my career to adopt this fudging factor. And now people are using again to explain dark energy. So you explain that. But basically, those are the 2 points that I would like to show with respect to prograde and retrograde motion. So let's see this in a more animated way or fashion. If I do a small change, and that is, I will fix it now fact, let me bring some nice constellation of zodiac here. See, I like this region here with Orion, Taurus, Pleiades right there, Sirius right here. So, and I will allow time to flow one sidereal day at a time. It's as if we were going above Earth's surface and then fix and stare at this region in the sky on and on and on and on, always seeing Sirius, Orion, Taurus, and Pleiades. So, and then I go one day ahead, another day, another day, another day. You see these times here keep changing. Another day, November 14, another. And there comes the moon. The moon is the first of the planets, ancient planets coming by from east to west. So moon seems to be in respect to the stars, and that's the point when we explain prograde and retrograde motion, you have to always say in respect to the stars, right? Because in respect to horizon, we see all of them moving from east to west, from our left to our right-hand side, in respect to horizon. But in respect to the stars, we see the moon always prograde, and there you go. So which one is the next one to come? The moon again, another month has passed. So moon always prograde, always. Moon never retrogrades. Look at Mars. Mars is coming now, and Mars prograde. Mars is prograding still. And the moon comes in again. And now who's coming to join the party? It's the sun. And the sun also progrades, and Mercury and Venus. Oops, what's happening with Mercury? Now they are all prograding. But Uranus is slow. Mercury is passing the sun now. And look at Mercury. Mercury will start retrograding. Now Mercury is retrograding. Totally retrograding. And Venus is still prograde. And now Mercury progrades too. So I don't know if you could, if you close your eyes for a second, I will go back up in time. So keep your eyes closed. And see if you can imagine the orbital path of Mercury around the Sun. Let me speed this up. There you go. I don't know if you could visualize this circle, or an elliptical, in fact, indicating Mercury's orbit around the Sun. And as we see it, sometimes prograde, sometimes retrograde. In ancient times, this couldn't be distinguished. First, we don't see and feel Earth moving in the sky. We don't feel Earth rotating in the sky. The argument of wind was a strong one. Well, if Earth is rotating and moving in space, how come we don't see the wind, feel the wind? And science in those days were dictated by four elements: earth, water, air, and fire. And Earth, everything should go to Earth. So Earth, as being the center of the universe, everything falls towards Earth. That's why no matter where you are, things falls towards Earth. And fire, which in those days was considered a noble element, associated with spiritual things and gods and whatnot, when you light up a match, the fire goes up towards the heavens. So that's their science in those days. Right? So we don't have that type of argument nowadays to explain phenomena. Basically, that's what they did. Now, when Galileo came in in 1600, he brought with him testing. And that's when we agree that science became what we do nowadays. Science is not just a process of observe how nature behave and take notes, like Mesopotamian did, like Chinese astronomers and philosophers did in the past, like Indian astronomers and philosophers did in the past, or Greek philosophers did in the past, not just to take note and even build technology. Nowadays, this just by per se doesn't identify what we consider modern science. So Galileo, he opened one aspect of modern science that didn't exist before, and that is testing your 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 hypothesis or your ideas. So you observe things, you take notes, you create empirical laws, you write them in mathematical format. That's great. But once you've done that, you have to explain why this happened. And when you explain, you have to include in your narrative aspects and elements that you can go in a laboratory and reproduce. You cannot say, okay, Apollo is the one guiding the sun from east to west. And because Apollo is a hot dude, that's why daytime is hot. So you cannot come up with this type of argumentation because I don't know who Apollo is, and I can't bring it to my laboratory to measure its mass or its characteristics. So you can't use this argument. You can't say that God's the one doing things because you cannot summon God, you cannot constrain God, you cannot define God in measurable ways. So that's not part of the discussion. And that's why sometimes in some people with strong belief system, they think that science is against religions or God or this and that. I mean, I know scientists that are very religious. Science is a method; it has its own way, and it so happened that all these other elements of human society are not incorporated into its explanation. Um, Again, talking about teenagers, they always want money. Um, um, the pretty much that is uh, is the aspect of modern science. When you have a theory made, the theory has to be good enough to explain what you have, the volume of data you have, but also some good theories can predict things that you have no idea, and at that time you have no technology to test it. So, like gravitational waves that was predicted a long time ago, there was no technology to to prove it. So it proved to be right because now we have technology to measure it. So that's how science works. Science incorporates in its discourse things that you can reproduce in other labs. It's a universal language to find out how nature operates, how nature works. So this subject is dry, but it's fun if you can get it, right? I would like to leave you, unless you have some question quickly. See if I can do something here quickly to show how much of these ancient thoughts happen to be incorporated in our society, and for that, um, let me show something quickly here. Mm, where is it? Okay. Um, So go to ancient days or ancient times, and in the geocentric worldview, in the geocentric, you have Earth, right? So pretty much Earth, and then you have the Moon, and then you have Mercury, and then Venus, and then Mars. No, I'm forgetting something here. Venus, and then Sun. Because Sun was placed in regard to in the place of Earth in the geocentric worldview. So Sun, and then Mars, and then Jupiter, and then Saturn. So again, so you have Earth right here, and then you have the orbit of Moon, then Mercury, Venus, and then Sun, and then Mars, and Jupiter, and then Saturn. Okay. Now, bring the moon into this consideration because the moon, and I think our book mentioned that moon was the sublunar, was the point dividing what is Earth and decayed to that which is divine and eternal, right? So Earth was was the point where if you are here, you are going to decay, right? So if you go to heavens, you're going to stay forever. You're going to be immortal, things like that. And the moon was the dividing line. So moon was associated with practice and meditation. And if you go to temples, the day was divided in four parts because of the four uh, main phase of the moon. So, and then you do something like this. You take the day and then divide it in four parts. And you have from 0 in the morning to 6 a.m. Then you have noon. Then you have 6 p.m. And then you go back to midnight, right? And then you say, okay, so you start the week on Sunday, which is the day right here, is the day of the sun, right? And the most important part of the day is the one that you do meditation, communicate with the major God of that day. So, and then we start with Sunday, the day of the sun. And so, and then you start, okay, this is sun right here, sun. And then you go to the next one is what? Jupiter, no, Mars. And then you go to Jupiter, Saturn, and then you are in another day, right? Sunday, and then you go to Mars, Jupiter, Saturn, and then you go to the next day, which is the day of the moon. So you go back here. So you start here, right? One, no, start here. First day, first part of the day, second part of the day, the third part of the day, the fourth part of the day, and then you are in the next day, which is the moon. Yeah. Now, then in the first part of the day, on moon day, then you meditate to the moon, right? And then you go to the second part, you meditate to the next, and to the next, and then to the next. So we are here, Mercury, and then which this is Venus, and then you go to the Sun, and then you go to Mars. So the day of Mars. And then you are here, right? And then you go, so on Mars day, first part of the day, from 0 to 6 a.m., you wake up at 3 in the morning and you meditate to Mars. And then you go to the second part, third, fourth, and then you are in the next one, Mercury, the day of Mercury. So the day of Mercury. So if you know Spanish or French, you know what I'm talking about. Mercury, right? Isn't that Mercury? I don't know Spanish. Do you know Spanish, Travis? Probably not.
No.
So, but it reminds of Mercury, Day of Mercury. That is Wednesday, basically. And then you are here, and then you are meditating Mercury. Where's Mercury? Right here. And then you go to the second part of the day, the third, the fourth, and then you have the next one, which is Jupiter. Jupiter, the day of Jupiter, which is the day of Jove, which is, I think is in Spanish, I think. I'm not sure. But Jove is Jupiter, and also Thor. Thor is the equivalent of Jupiter in the Nordic um, tradition.
Thursday.
And then it's Thursday, right? Thursday. So, and then you are in Jupiter, or it's Jupiter here, and then they'll meditate on Thor on the first part of the day, on Thursday, and then you go second part of the day, third, fourth, and then we are here on, what is this? That's Venus. Yeah, that's Venus. So the day of Venus, which is Viernes. Viernes. I don't know, because we have Friday night. Viernes. That is Friday. That's Friday. And then we are here on Viernes, and then we meditate on Venus the first part of the night, the day, and then the second, third, fourth, and then we are in the day of Saturn, Sábado, Saturn day. So the days of the week, the way they are, is a combination of a in fact, geocentric worldview and the moon, and practice that were used in the past in temples. Most of it related to Christianity, where all of these ideas were developed. Oh, and again, messages of teenager. But that's it.
Isn't it fun?
It is fun. Yes, it is fun. So what I'm gonna do now, Travis, probably you don't need it, but I need for the rest of the class. I'm gonna go over those moon phases, extra credit.
Mm-hmm.
So, and I'm still taping, so I hope everything goes fine. But for those of you, I launched an extra credit 2 weeks ago, a week ago, but on the process of uploading, it didn't go through. So I'm gonna show you the extra credit, the questions, and then you answer. Just posting the answers. In case you can't find an explanation to it, I can try to find a time and publish some video explaining what you should do to determine and to name moon's phase in the sky and to make predictions of when they are supposed to rise and set. Okay, so let me stop sharing this for now. Let me pull that up. To find what it is. I'm gonna get there. Okay. Alright, so let's share the screen. All right, so here are the questions you have to answer to get extra credit. So there are basically 9 questions. They have to do with the moon's phase and time of the day this moon phase are supposed to rise or set or depend, or if they are going above horizon or not. In all of these exercises, we are assuming we are seeing the moon from the northern hemisphere perspective. Okay, so the first one, I will give you the answer of the first one. In the northern hemisphere, the following moon phase is a what? New moon. I don't know full moon. So in fact, it doesn't matter, right? So if the moon blocks the sun, this is a solar eclipse. The moon must be in the new phase. So then you would upload an answer. Question 1, answer is new. Question number 2, which moon phase this is? So we have those options over here. Next one. There you go. This type of questions you might see in the exam. So if you are not understanding or you don't know how to get them, ask me. I can pull up a quick explanation, quick trick so you can do these things. Question number 4. Question number 5. By the way, the question number 4, I can tell you one thing, is not full, right? See, this part of the moon is not complete. So it's not a full moon. Question number 4. Question number 5. About this. Question number 6. Question number 7. Number 8. Number 9. Oops, wait a second. It's just 9? Yeah, only 9 questions. That's it. All right. All right. Good night to all of you.